Good afternoon, everybody. Hope everybody's doing well. Okay, this is a pristine example of a Scott 299C amplifier. And what I'm doing is just some preventative maintenance. I'm going to replace the high voltage power supply capacitor. This capacitor here has the most voltage on it, on the two capacitor sections that are inside here. So this is the one that's been most abused over the years, since it has the highest voltages across it. And then going down the line in the power supply, here's the other high voltage one that's also a, where is it? This one right here is also a 30 microfarad, 500 volt capacitor. That's the second one in the power supply chain. Not as, abused as this one, because this one here comes right off the 5AR4. It's the first one in line from the 5AR4. I think there's a resistor in between the two, but so I'm going to replace it. I already replaced one of these in an LK72, which is the kit version of this, and here it is. Here's what it looks like. And I brought it to work and measured it, and there was actually nothing wrong with it. Here's the microfarads, 46 and 49. And as far as leakage current, I did it at around 440 volts DC. I got 2 milliamps and 1.5 milliamps. So I don't think that's too bad for a very old capacitor, about 60 years old. So, but I changed it anyway for preventative maintenance. And this is the replacement one I'm using. Smaller, more compact. Hopefully it's as good, the quality is as good as what I'm removing from the amplifier. I'll show you the front. Everybody knows what this is. Beautiful 299C. This is my dad's amplifier. He bought it brand new back in the day. I've used it through my high school years a little bit. And now I finally brought it to my house. I would not take the amp from my dad's house, because just in case he wanted to use it. And he had recently passed away in May of 2019. God bless you, Dad. I miss you. But taking care of the amplifier here. So, all right, let's get started. Okay, so if you've never worked on a tube amplifier, you probably shouldn't be doing this. There's high voltages in here that can kill you, up to almost 500 volts DC and 120 volts AC. Actually, almost 700 volts AC. So depending on where you touch. But please don't work on this unless you know what you're doing. So what I'm going to do first is just connect. These are just 8 ohm resistors. I'm just going to connect them to the speaker outputs. And then I'm going to take an initial measurement of the voltage on these two capacitors in here. This way I can have before measurements and after measurements with the new capacitor to see if there was much change in the voltages. And we'll see. We'll take it from there. I don't have my capacitance meter here with me, so I won't be able to really test this original capacitor right now. So here's the beautiful 299C. I have 6 U8As in there. This is a 7199 amplifier. It has it came it uses the 7199 phase splitters, which I still have and use, but I wanted to try the 6U8As, and they sound good too. I bought these little adapters. I don't want to get off subject here, but so either one, 7199, 6U8As, they both sound good to me. So let's get started. Okay, here's the can with the capacitor we're replacing. And if you could look, let me just focus here. The triangle part has an orange wire going to it. And the semicircle part on the bottom down there has a red wire going to it. Then on the can part, which is the negative, we have one of the transformer wires going to it. And down here, also to the can, there's a black wire. So basically, two wires going to the negative side of the cap, and then you have your orange and your red going to the positive sections of this capacitor. So I'm going to just take the voltage readings now. Really quick here, I have my light on so you could see. So you see orange wire goes to this one, red wire to the bottom one here, then the transformer goes to the negative here, and there's a black wire down there goes to the other negative. So the way you get, so we're going to remove all these wires by cutting them. They're long enough that you don't have to unsolder them. Just cut them very close to the terminal. And then we're going to twist these things. You have to twist them to align with the slot, and then the can comes right out. The new can, I have a bracket that will mount the new can. So I'm going to drill 2 holes and mount it, because they don't have the same, they don't have these tabs that you stick in these slots and then bend. So we're going to mount it with the bracket that came with it. Okay, the bottom capacitor with the semicircle, it's marked as a semicircle. You see it there. The semicircle, that's the one that comes directly off of the 5AR4. See the red wire there? That comes down, snakes over there, goes. So we're going to do the semicircle first measurement, then we're going to do the triangle section. These capacitors are the same value and the same voltage, but in between them is a resistor, so one's going to have different voltage. I'm going to fire up the amp. Let's watch the voltages. This is on the first section of the cap. Look at that climb once that 5AR4 starts going. So this is coming right off the 5AR4 rectifier, holding steady at around 472 volts. Okay, I'm going to speed up this section and just show you my readings on the pad. That's the first section, 472. All right, the old cap is out, and here's how they were mounted. There are 4 slots and a piece of phenolic. I believe that's phenolic. And so 2 of those tabs that go in these slots, there were wires soldered to. But you got to break them off. I really don't know how to get out of there without, you just twist them off. You could try to, even if you twist them back aligned with the slot, they're not going to come out because it's almost like a herringbone type thing. there are some stops on it that prevent it from coming back through. So what you do is you get all your wires exposed, so you can, I cut them as close as possible to the original tab. So I have an orange, one from the transformer, a red, and a black. Now I'm just going to strip these wires. I have nice access to them, so it's easy to strip. I'm going to drill 2 holes in the chassis. I prep the new capacitor by putting the clamp around it. I didn't tighten it yet because I don't know what height I want the capacitor to be at. So, you know, maybe I want more of the capacitor under the chassis, or, well, I want it, you know, I want it to be right. So we'll see. I mean, it's going to stop when it hits this piece of phenolic anyway, so that will determine my height there anyway. So that's how I'm going to adjust this clamp to. So I'm not going to show myself drilling the holes and stripping the wires and mounting, because that's just kind of boring. And all you have to do is, I use 2 6/232 screws. These are 6/32 screws. You can use Loctite on them or lock washers. On my other amp I used 832s, and I found them to be a little large, and they get in the way of things. So here's my 6/32 screws and nuts. Okay, see you in a bit. Okay, this is going to be the final location of my capacitor here. What you want to do is you want to get your mounting holes where you can drill a clear, you know, where you have a clean shot to drill a hole. Not, you know, you're not going to do it here by the phenolic piece. So I have a clean shot there and there to drill my mounting holes. Now, I know some of you guys are going to say, well, why don't you just drill out the old phenolic piece? I know I could do that, gentlemen, but I'm going to leave it in there. I have my reasons. So I'm going to leave my phenolic piece in there. I'm going to drill my 2 holes. One there. I'm going to mark it with a Sharpie, make a dot, and then drill the holes. And this thing is not going to be going anywhere. This mounting is very good. I have it a good enough distance away from the transformer. Transformer does get warm. Not that warm, but it gets warm. So once you have your clamp mounted, you could put the capacitor in. You have a, you know, you can rotate it, but it doesn't rotate because it hits the phenolic piece. So you basically... Okay, I like having capacitors, you know, this, it's easy to see the capacitor information. I also rotated the clamp a little bit differently. So I have the stability tab resting on the phenolic here. See where my finger is? You want that tab resting on the phenolic. And if you look back here, it's resting, this one's fully on the phenolic. So that's going to give the capacitor stability, and it's not going to wobble. So this one's like halfway on the phenolic, and that one's 100% on the phenolic down there. So this is where my clamp's going. I just changed the, I rotated a little bit. So I'm gonna now I'm gonna drill, mark the holes, use my center punch, drill them, and mount the clamp. You could do this all without the capacitor around, so you don't damage the capacitor. Okay, as you can see, before I strip my wires, and this part is trial and error, where you're just going to be rotating the capacitor, and when you're happy where the terminals are, see, this is still loose. I have my ground, my negative on top, and my 2 hots, my 2 positives rather, on the bottom. I know all the wires will reach. The capacitor looks good on the top. This is the way it's going to look on the top. I could still see the label if I want to. And my holes are lined up. And make sure before you make your hole marks, make sure you tighten the clamp on the capacitor body, because when you tighten the clamp, those mounting points move a little bit. Those two tabs with the slots in them on the bottom, those move a little bit. So make sure your cap is tightened, your clamp is tightened on the capacitor. So now I'm going to finally use my center punch, which is a device that makes a tiny divot in the soft aluminum. This way my drill bit won't skate when I'm drilling the two holes. And also make sure you're not drilling through anything important underneath the chassis, like wires or components. It's pretty clear here, but just double check that, because I didn't check that yet, so I may have to change my mounting locations. Okay, I cleared everything out of the way. Now I'm going to punch these. That's one. And that's two. Ready for drilling. It's all mechanically done. On this side I used two take-up washers due to the thickness of the phenolic piece there. So in hindsight, this job would be maybe easy if you remove the old phenolic. But so anyway, this is very tight. This is securing the capacitor. And the tab on the bracket is everything's snug. The nut is tight, and that blue stuff is Loctite. So this is tight. The Loctite will prevent it from anything from vibrating off. This side doesn't look as elegant as that side because I wasn't able to get the take-up washers underneath the tab from the capacitor. I'd have to channel out. Maybe I could channel out some of the phenolic, and then I'll be able to fix this. And get two washers is all you need to take up the thickness of the phenolic, so that tab sits flush. This one I tightened, but I didn't really tighten it hard because I'm not trying to bend the bracket down. It's tight. It's not going anywhere. There's Loctite there. You could probably lift the whole amplifier from this capacitor. Okay, the hard part's done now. Everything else is just soldering 4 wires. Smooth sailing. Okay, I have my wires all ready to be soldered. There's the wire from the transformer here, and the black wire that goes to ground, and and then the orange and red go to each of the 30 microfarad capacitors. They're looped in there, and the reason why we loop them is just in case you do a bad soldering job and the wire gets loose. It makes it difficult for that wire to fall out and short out against something. So that's why we usually wrap it, make like a hook with the end of the wire. So all these are hooked in the holes, if you see closely. Got the black one hooked in there, and the stranded wire from the transformer on the negative. And then I have my orange and red all hooked and ready to solder. Now I only have 2 hands, so I can't show you myself soldering, but I'll show you the finished result. Okay, I just cleaned my solder joints with Q-tip and isopropyl alcohol. That's why you see a little wet there on the bottom of the capacitor, but there's your 3 points that you have to solder. Everything looks great. I just wanted to show you before I move the other wires back and on top of it, then you won't be able to see. The insulation burned back a little bit on the red wire, but it can't short out against anything. I could always put a piece of tape on it. Worst case, I'd have to disconnect and put a piece of shrink tubing or strip it, cut it and restrip it. Or just cut it and put it back in the tab in the capacitor and solder it. But that's not going to be able to touch anything. And that's it. Let's check the voltages to see if they changed between the new cap and the old cap. Sum up. By the way, I couldn't take the AC readings. This meter is just a cheap meter, and it wasn't giving me a correct reading for the AC ripple across the capacitor. but the DC voltages, as you can see, are very close. So that tells me that the health of the old capacitor was very good. But, so you're like, well, you just wasted 3 hours. I'm like, no, not really, because now I don't have to worry about this thing shorting out or having dielectric breakdown and, causing other damage in the amplifier. I have a reliable cap that'll last another 20, 30, 40 years, who knows. So I still have my clip lead on the capacitor. I'll take one more shot from the top so you can see what the amp looks like. Okay, here's the finished product.